tuntuba kan zirtur hi physics unit 8 chapter 1 ani atoms and nuclei atoms aka kan ron zirle don ani voina uluk takin in lo ngai thanga thiam tumin in lo ziranga derivation thui tak kan ti dona in le khabu te khain lo la chuak don nia le ama sabera chuan Bohr's theory of Bohr's atomic model ti hi ni Bohr sakhan atomic model kha lo siam chuaka khami of atomic model a siam chhuah khan hi a model a chu ni electron hian charged particle nucleus heavy charged particle nucleus chung om kha electron khan akal hualani a revolve around the nucleus ani apanina chuan electron ho khan an du na orbit a khan in nucleus kha an kal hual top theilawani ta hian conditioner on siam ta ni electrons can revolve around the nucleus only in those orbit in which the angular momentum is an multiple of h by twice pi ani omzia chu hei angular momentum ania hemi angular momentum heti zat an nei na orbita chau khan electron khan an revolve theiani tin pathumna chuan energy kha ground state energy te first state energy second te khan energy level chi sang kharon omta higher energy level atanga lower energy a electron a jam khan energy kha ape chhuah kan in the form of radiation in kha Bohr san atomic model aron siam chhuah choni Bohr sama khan Rutherford khan atomic model kharon siam chhuah ka khami Rutherford atomic model kha dikhlelna oma wangin Bohr sen atomic model chi sang kha aron siam chhuak vele ta hei hi ani Bohr sa atomic model atang hian hemi atang hianin electron ina nucleus positively charged particle a revolve a kal hual na a energy nei te a velocity te a radius engzat ngei ani ti te kha voina hianin hydrogen atom mangin kan zir don ani le Bohr's theory of hydrogen atom hi kan zir tur achuni ta ni hydrogen atom kan lak kher na chan chu hydrogen atom hi simplest atom ani electron pakhat aneya proton pakhat anei ni chuta tang chuan a zero ol sama wangin hydrogen atom hi kan ron mang don ta ani hemi hydrogen atom atang hianin engzat nge eng radius in nge electron kha revolve anga eng ang velocity a chakin nge akalanga tin energy engzat nge aneyang ti kha tuna kan cho chhuah tur chu ni athui deuh hleka uluk dawinin lo ngai thadon nia le kan hriat agin kan soi to angin hydrogen atom a chuan electron pakhata oma nucleus pakhata chuan proton pakhata oma chumi nucleus chu electron hian akal hualani ti hian heta positively charged particle alaya a oma electron khan ti hian akal hualani ti hian electron ti khan positively charged particle nucleus omi electron khan ti khan akal hela ti hian an kalani hemi akal na hianin electrostatic force of attraction kha donani positive charged particle ania alayami hi negatively charged particle ani electrostatic force of attraction coulomb force kan ti kha anin kara hian inhibit na kha donani khami coulomb force kha the electrostatic force of attraction chu engen yang coulomb force mang khan F is equal to 1 by 4 pi epsilon naught more Q1 Q2 by R square ani kha hemi here revolve na a radius kha R kan tiang more this 1 by 4 pi epsilon naught ania charge kha electron le proton ania separated by distance R square hei kan lak chuan 1 by 4 pi epsilon naught E square by R square ani hei equation number 1 kan tiang mom chuan hemi electron hian it is moving it is having a mass m anei ni chuan a revolve khan it will move with some velocity nei in a move don ani so ti chu hemi hi centripetal force omani akwala akala wangin centripetal force omani the centripetal force anin kara khan centripetal force om dona khami centripetal force kha mass m neya velocity v in akalani chuwang chuan hemi centripetal force hi mv square by r ani mo hi equation number 2 kan tiang le hemi centripetal force hi engwanga ron nge kan ti chuan hemi le hemi in hi tlat na electrostatic force of attraction awang khani in hi tlat lo seng chuan electron hi a thlok chuak dei don ani ma sen in hi tlat awang khanin centripetal force chu hemi force hi ani chu ta chu mi zia tu the centripetal force is provided by the electrostatic force of attraction chu wangin centripetal force le hei hi anin tlukta ani mo the necessary centripetal force hemi centripetal force hi hemi electrostatic force of attraction wang hi ni chu wangin hemi hi a centripetal force chu ani ti na ni chu wangin mv square by r is equal to 1 by 4 pi epsilon naught e square by r square ani nakina hei le r le hemi r pakhathin cancel theya tuti chu hwadui nge kan nei le mv square by 1 by 4 pi epsilon naught e square by r hei equation number 3 kan tiang mom equation number 3 thleng kan nei ta ti khan lenichina Bohr's theory of Bohr's atomic model atanga kan mu kha electron can revolve around in those orbit whose angular momentum is an integral multiple of h by twice pi inti kha khami kha kan mangang according to Bohr's quantization mvr is equal to nh by twice pi hei hi equation number 4 kan tiang or v is equal to nh by twice pi mr. We'll name this equation number 5. Le using equation number hemi equation hi equation number 3 akan mangang equation using equation 5 in 3 le equation number 3 kan mv square is equal to 1 by 4 pi epsilon naught e square by r ania mo instead of v value ki he tami hi ta hian kan substitute don ani chuti chu enge ni tang m v kha nh twice pi mr square is equal to 1 by 4 pi epsilon naught e square by r ani ta ni heta tanga ron chuak le ta chu r value the value of the radius hemi hi kan cho chuan radius value kha lo chuak don ta ni 1 by 4 pi epsilon naught n square h square 4 pi square me square hei hi radius of the electron ina hemi nucleus an revolve na radius aka hemi equation hian min ron pe chuak ta ni hemi equation atanga in hmu tur chu 4 pi epsilon naught chu constant ani h po Planck constant ani 4 po pi po mass of electron po constant mo electronic charge po constant ani so wangin the only variable term is n hi ni principal quantum number kha r is directly proportional to n square so mi zia chu radius hi khami a orbit na kha san zel chuan n value san zel chuan a radius kha sang zel don ti na anita ani le a radius akha kan chuak to a tuna chuan atom kha exact velocity in nge a revolve ang ti kha tuna hyang kan chuak le don ani le equation kha hei hi kan nei to sa kha ni v is equal to nh by r ani le ta khan Bohr's radius kha r ani hi Bohr's radius kan chua to kha ani chuwang chuan instead of this r hei hi kan substitute ve thung don ni direct in ka substitute nga reciprocal ka langal don nia v is equal to nh by twice pi m 1 by 4 pi epsilon naught kimi Bohr's radius value ki ka substitute nia 1 by 4 pi epsilon naught 4 pi square mc square divided by n square h square hei hi Bohr's radius kan chua to kha ani ta ni chona in cancel thei kan cancel anga true pi pakhat le heta pakhat hei le hemi pakhat hei le hei hi le chuti chu radius chu enge chip bang ta 4 hei le hei hi la om bok 4 pi epsilon naught v is equal to 1 by 4 pi epsilon naught through e square divided by nh. Hei hi the velocity of the electron revolving around the nucleus chu hei hi anita ni mo heta pi pakhat ala om mo hei hi velocity kha hei hi anita ni heta tanga ron lang chiang ta chu v is inversely proportional to n ani muzia chu orbit kha asan pole a velocity kha atniam zel don ti na ni chu a revolve na velocity kha atniam hle don ti na ani chu le tuna chuan exact energy in nge electron ho kha an revolve ang ti kha tuna kan chu chhuah le tur chu ani ta ni energy of the electron. Let ek and ep be the kinetic energy and potential energy respectively. The total energy of the electron revolving around the nucleus to the potential kinetic energy plus the potential energy ani electron ka mass m anaya it is moving with the velocity v ani vangin a kinetic energy to the kinetic energy ek to half mv square ani le half mv square ani to half mv square ani equation kan lo nei to mv square value hi ta hian ka substitute don ani half 1 by 4 pi epsilon naught e square by r, or we can write it as 1 by 4 pi epsilon naught e square by twice r. Kaka energy of the electron, a kinetic energy of the electron ani tuna chuan the electrostatic potential energy kha kan chui chuak leang the electrostatic potential energy chu electrostatic in zirto ang khan electrostatic potential energy chu hei hi anita ani minus 1 by 4 pi epsilon naught e square by r le tuna chuan total energy kan chu chuak thei ta a kinetic energy total energy chu kinetic energy plus potential energy ni kha kinetic energy kan nei to a potential energy kan nei to a chu wangin tuna total energy chu kan chu chuak thei to don ani kinetic energy 1 by 4 pi epsilon naught e square by twice r minus potential energy tuna chona total energy chu kinetic energy plus potential energy ani hei hi LCM in langa chuta answer lo chuak tur chu minus 1 by 4 pi epsilon naught e square by r ani hei hi energy of the electron revolving around the nucleus ani heta mai henala top to lo ni hemi r value heta Bohr's radius hi heta hang kan substitute le don ani heta r value Bohr's radius kan han substitute khan heti hian alo omta hemi value kha chuan kan han cho khan hei hi energy of the electron revolving around the nucleus chu hemi equation hi kan nei chu ni ta ani hemi equation atanga ron lang chiang chu energy is inversely proportional to n square ani 1 by 4 pi epsilon naught constant ania 2 pi me an vai hang constant ani h po Planck constant ani variable term chu n chia hi ni so wangin e is inversely proportional to n square hemi standard value substituting all the standard value hemi standard value zong kan substitute nu chuan substituting all the standard value e value hi thiana ron chuak ta ni minus 13.6 divided by n square electron volt heta hian ron chuak ta ni zona in nei mai thei ni engating energy hi negative ani ti kha zona om thei ani kha zona om reng ani a chan na po energy chu hemi hi negative ani na chan chu electron kha uninbound tlat ani tina ni mo electron hi unbound na nucleus a inbound tlat ani ti en tirnan hei hi a negative value alo chuak ta ani hemi energy hi n is equal to 1 ani hian n is equal to 1 ani hian e is equal to minus 13.6 ani ground state level anti chuni tahan energy of electron hi atlem berani negative a chuan a number tam kha tlem ani khamo chuwang chuan hemi negative value ania hemi ground state n is equal to 1 a chuan hemi value hi atlem berani n is equal to 2 a chuan e is equal to minus 13.6 divided by 2 square lo ni tonga hemi e value hi alo niam le tong ma se negative po ni ma niam ma se negative ani awangin hemi ground state energy ai chon hei kha atam jok don ta ni heng ho kha atam jok zel energy kha excited states anti chu ani chuwangin energy te a velocity te a radius te kan chu chua ka khatiang ho zong kha uluk dewin lo ziranga a solution a thui dewa tin chin chia tur te alo tam dewa takin in lo zir don ania unit 6 chapter 1 ani optics ti ani optics a hian chihni kan zir dona 12 a hianin pakhat na chu ray optics ania ray optics chu class 10 ate po in zir to convex lens concave lens te in tia image formation te in ti kha khang kha ray optics kan ti chu ni voina han ray optics chu kan thlur big deuh hlekanga wave optics chu anu le lama te po kan la in zirtir le anga tlem te po na har zok ve dewa ray optics ai chuan ray optics a chuan kan rilruar lang masaber chu reflection and refraction of light kan ti khani reflection of light ti hi kan zir kan en le thuak masa anga reflection of light. Reflection of light kan ti chuan reflection is a phenomenon of change of path of light from one medium to the same medium without any change in medium. Change in medium omlawa ray of light ina an path a change a in thak nakha khami a phenomenon nakha reflection of light ani reflection theihna tur chu kan thevek nga dar thlang kan in en na dar thalang te heng te hi reflection na vek ani ti chuan reflection of light chu diagram mang chuan ti hian kan ziak thinani hei hi reflecting surface kan ti khani heta incident ray alo kala incident ray lo kal ni incident ray na reflecting surface atlak adda asudna chi a hian 90 degree a tia kan zia hi hei hi normal anti chu ni hei hi normal hei hi incident ray hemi incident ray hi hemi reflecting surface atlak chi a hian hemi hian apa takha athak anga ti hian aron chule don ani mo hei hi reflected ray chu hei hi ani ta ni incident ray le normal in kara angle hi angle of incidence reflected ray le normal in kara angle hi angle of reflection ani reflection hian lo reflection of light hian lo chihni pahni anei ani chumi lo chu in sevek to ang karinga the incident ray the normal and the reflected ray all lie in the same plane ti kha alo pakhat na chu ani law number 1 the incident ray alo pakhat na chu the incident ray normal and the reflected ray incident ray normal le reflected ray hi they all lie in the same plane ani apahni na le hi apoi mota ni the angle of incidence a second law chuan the angle of incidence is equal to angle I is equal to angle R hemi law pani hi law of reflection a kan nei te chu ani adota kan zirle tur chu refraction of light ani hei po hi in hriat vek to no nia class 10 a refraction of light hi chu change in the path of light when it goes from one medium to another medium ama kha chuan in reflection a ka chuan medium ngaya air ani chuan air a bokoron chhuak leang tuna chuan light kha medium pakhat atengin medium danga akal tlang le don ani kha refraction of light anti chuni hei hi refracting surface ani example glass slab te pon yang refracting surface ani incident light ti hian aron kala incident light tlak na tak ka line kan zia kha normal kan ti kha normal hei hi air ti chu glass ai chuan alo rare deuh ni a medium kha alo a density te kha lo claim deuh ni rarer medium atanga denser medium alu khan light kha it will bend towards the normal hei hi angle of incidence ania hei angle of refraction ani hei hi refraction a light kal dan chu ni denser medium atanga rarer medium atanga an chhuah chuan the light will bend away from the normal ani entirnan hei hi glass slab ania glass slab atang han ray hi ron chuak ta ang se ti hian hei hi normal ania hei incident ray ni glass atangin dense atangin rare a ron chhuah chuan hemi refracted light hi it will bend away from the normal hei hi angle of hei incidence ania ngei hi angle of refraction ani hei hi light kaldan ani hemi hi it will bend towards le away from the normal ani theihna hi nakina karon cho pui don chewani le refraction po hian lo chini pani anei ani pakhat chu amami ang bokhan alo pakhat na chuan the incident ray normal and the refracted ray all lie in the same plane kha alo pakhat na ani alo pani na hi apoi mo the sine of the angle of incidence to the sine of the angle of refraction is constant in kan zirthin ani hemi constant hi refractive index ania hemi refractive index hi it is denoted by a Greek letter mu n te pon an denote nga text budanga mu te po denote amangma se refractive index ani ti kha in sin sia tlat don nia hemi lo hi apoi mo mani hemi lo hi aming pakhata chuan snail's law antibok thin hei hi snail's law antibok khani nakina hemi hi light hi engatinge towards the normal ania away from the normal ani ti nakha hemi lo mang te hian kan ron chu chui chua kanga tin hemi lo hi man na tam ema in lo sin sia don nia sine of the angle of incidence to the sine of the angle of refraction is constant. That constant is called refractive index ania mu in ka denota ka soito ang khan n ponan ron denotang hei hi refractive index anti chuni le refractive index hi a formula a chuan speed of light in air divided by speed of light in a medium tepon an chui chuak ve thin bokani le absolute refractive index ni china sine of the angle of incidence to the sine of the angle of refraction a mu kha a definition a chuan speed of light medium ani annotation a chuan c is speed of light in air so ina khania speed of light in a medium chu v ani hei hi unitless quantity ani asan chu helam hi speed ania helam po speed ani a unit kha in cancel dona chu wangin refractive index hi unitless ani ti kha in sin sia bok don ne oh hei hian unit anei lo refractive index hian hei refractive index ani hemi mang hian anything a light hi bend towards the normal ani a bend away from the normal ani ti kha kan ron chui chuak don ani refraction don chana chu light shim hi medium pakhata tanga medium pakhata luhen a speed hi in thla kani rarer medium a chuan akal chaka denser medium a chuan light hi akal muang ani the velocity decreases when light enters to a denser medium ani kha khami mang khan hemi bend away from the normal let towards the normal kha kan ron soifia don ani kha cause of refraction anti chuni cause of refraction bent away from the normal let towards the normal karon a chhuah dan khain lo chin sia don nia tuna kan chok don ani light hi rarer medium a chuan a velocity kha v1 ni se chin denser medium a velocity kha v2 ni se mo ti chuan light hi rarer medium a chuan a kal chak zo ka wangin v1 is greater than v2 ani let's snail's law atang khan from snail's law. Snail's law khan sine I by sine R is equal to refractive index ani. Refractive index khan enge formula kan ti kha speed of light in air divided by speed of light in a medium ani. heta hi chuan speed of light in rarer medium to speed of light in denser medium ani v1 by v2 ani le since v1 is greater than v2 I is greater than r hemi zia chu speed of light v1 hi v2 ai atam chuan angle of incidence hi angle of refraction ai atam zok don ti na ni ta ni angle of refraction hi atklem zok chuan angle of incidence I claim chuan it bends towards the normal. This is why light bends towards the normal. Adot le chuan when light travels from denser medium to rarer medium ani le v1 hi speed of light in denser medium kan tianga v2 hi speed of light in rarer medium ani a dense kha chuan speed hi claim don ani a rare a chak zok chu wangin v1 is smaller than v2 ani hei hi from snail's law kan soile chuan sin I by sin R is equal to V1 by V2. Since V1 is smaller than V2, sin I is smaller than sin R. So that is I is smaller than R. More angle of incidence ka angle of refraction ay na claim zok don ani. So wangin angle of incidence heti hiya na law amta angle of incidence hi. Hei hi angle of refraction ay na claim zok chu ti chu angle of refraction chu he tia omangai ta ti na ni hei hi rarer denser medium atringin rarer medium aron chhuak ani hei hi a omzia chu ni mo this is why light bends away from the normal hei hi denser atanga rarer chhuah le rarer atanga denser chhuah light bends away le towards the normal so if ya nakha anita ani adot le kan Zirtirtu total internal reflection ani total internal reflection so it is a phenomenon of reflection when light travels from denser medium to rarer medium with an angle greater than the critical angle khatianga light kha denser medium atanga rarer medium aron chhuah critical angle ai tama light ka incident khan light ka refraction ni to lawin reflection ni alo ni to thina ni light entirnan hei hi medium ani denser medium ani hei hi tihian denser medium oma light ka dense atangin rare achhuak don ani hei hi dense hei denser medium hei rarer medium mom ani na taka chon heta hian refraction omani refraction ni turani tihian light aron kalta heta normal ania dense ratangin rarer achwa wangin it will bend away from the normal ani hei I ania hei R he tihian incident rei ka tihian kalta ni who there will come a point pakhatlo omang chuta chuan hemi angle of incidence englo hi refraction hi he takal to lawin he tia om hun lo thengang mo helai angle refracted ray hi hetia akala hemi angle tak angle of incidence ataka hi critical angle anti chuni hemi critical angle aya tamalai thi incident to chuan critical angle ai tamalai thi incident to chuan refracting surface po khanima se refraction om to lawin light kha a reflect to don ani heta hian heti zong hian hemi hi total internal reflection kan ti chuni hei hi chinchia ro critical angle ani critical angle a chuan angle of refraction hi 90 degree ni hemi critical angle ai tamalai thi incident khan refracting surface po ni ro se tui po ni ro se glass po ni ro se mo eng po ni ro se refraction ni ma se refraction am to lawin light ka avain reflection am to nga reflecting surface angena runom to don ani kha total internal reflection kan ti chuni total internal reflection am tur hian du huna thei lawani light hi dense atangin rare achhuak ngei tur ni rare atanga dense lu chuan total internal reflection am thei lo dense atangin rare achhuak ngei tur ani tin a angle of incidence kha critical angle ain atam ngei turani kha total internal reflection theihna tura condition pani kan nei chu ani ta ani le hi total internal reflection theihna tura condition pani chu kan nei chu ni ta ni light hi denser to rarer medium akal turani kan sei to ang khan rarer to denser medium akal chuan total internal reflection theilo ma tin angle of incidence hi critical angle hemi critical angle ayatam ani ngei turani chumi ni huna chuan total internal reflection theini hemi point pani hi uluk takin chin cheula in thei phei chuan memorize ngal ula thang question a chuang mun te mai nia le tuna chuan relation between critical angle le refractive index critical angle le refractive index hi engtin ngi an lo in relate ve sim te kha kan chu chuak don ani critical angle a chuan I kha critical angle C kan tiang mon chuan critical angle ni chin diagram kan en khan critical angle ani khan angle of refraction hi 90 degree ani kan ti kha in lam huanga ti chuan in snail's law mangin kan chok don ani hei po hi snail's law kha poi mu ka ti kha snail's law mang hian thil hi kan chok chuak de reng don ani le snail's law mang chuan mu b refractive index of medium B to refractive index of medium A sin C sin I turania hai critical angle ani wangin C ka da hai sin R turania sin R hi 90 degree ni wangin 90 degree ka dang mo to di chu sin 90 chu engzan nge sin 90 chu 1 ani so wangin mu A into 1 to di chu critical angle chu mu BA is equal to 1 by sin C. Hi relationship between refractive index and critical angle anti chu ni ta ni total internal reflection hi man na chi sang omani amma sabera chuan diamond te lo en na chan kha brilliance of diamond te le application of total internal reflection to brilliance of diamond ania mirage inti chu kan shaveka desert te kan ka ankala tui omlo na puya tui muanga nin sian na ang chi te khana in zirvek to optical fibers hi kan zira apoi mole ta chu poi mole chu ni optical fibers hi in shavek to nga he endoscopy ti te point om to nga ko chungan en na khamia shui an manakha optical fibers ani khata khan mora khan light to oma khami light khan pum tha te khan lata light pakhat ma abo bang am loin aron thon chwa ka heta computer screen a ten en chin kha khami kha optical fibers anti chuni optical fibers a hian alai taka hian optical fiber hian alai hian core anei ta ni hemi core hi a very fine glass high quality glass a siamani mo ti chuan chumi zo chuan cladding ti om le hemi glass lo tuam phui tu chumi zo chuan buffer coating ama chumi chu plastic thachi in an cover le thine ni hemi chunga khan light aron lu khan heti hian total internal reflection oma heta light lo lu thi ti hian hemi wire chunga hemi chunga high quality glass in atang khan total internal reflection khati khana om ta zela ti chuan heta chonga signal light lo lu te reng kha without loss of intensity light khan a en na bo lo nin a quality bo lo khan light zong kha they are totally internally reflected ti chuan khatianga ni wang khan thil kha chiang dewin ani na ango khan kan mu thei thi na ni chu kan soi tong khan nat na mu chhuah nan te endoscopy ti nan te mo light signal mun lat takatanga transmit nante mo telecommunication ti nante po khan optical fibers hi an mang thin ani lekhati zong kha tuntuma kan zir thei chu nia uluk takin lo zir leula poimo tak te kha kan zir le ni danga kan in hmule don nia